All right, so let's continue this problem. We set up our law of sines. We know we have little side, big side angle. We set it up. We said that angle A then has to be the arc sine of this. And I think I said something I said something not very well at the end of that last video. Remember, arc sine is only going to give you angles on the right half of the unit circle, from negative pi over 2 to pi over 2. Okay, however, we have to find the other positive angle. So it said, okay, 31.4 degrees is the angle in that in the range of arc sine. But where is that other one? So let's just draw this a little bit bigger for everybody. So we just found 31.4 degrees. What other angle, okay, also has a sine of 31.4 degrees? Well, remember, sine's y values. So then we just look at this. There's the y value. What other angle has the same y value? Okay, the angle that produces that y value there. Okay, so how do we find that? Well, we've got some symmetry here. That's 31.4. So this angle right to there is got to be 180 minus 31.4, which is 148.6 degrees. So we come back here and we say, or A is about, what did I say, 148.6 degrees. Okay. So, well, remember when I got this 31.4 degree angle, right away I popped those in and I said, okay, if this is 31.4, then angle C has to be 125.6. What I want to do now is I want to say, okay, well, if A was 148.6, what's angle C now? So here I'm going to take 180 minus 23 minus 148.6, and I get C to be 8.4 degrees. So with that, I see that there's two possible triangles. If A was 31.4, then I have 125.6 degrees for C. If A is 148.6, then C is 8.4 degrees. So we end up with two possible triangles from our little side, big side angle. So here's what I would do is I would say, okay, I remember our goal is to solve the triangle. So to solve the triangle means we know all the side lengths and all the angle measures. Okay, so I would say, all right, first scenario, A's 23, oh, excuse me, B's 23, A's 31.4. So we've got 31.4, 23, and in that case, C was 125.6. We knew side A was 8 and side B was 6. Okay. Now, we still have to find that one. Okay. And I'm not going to spend time in the video. You use the law of sines with this angle C now to find C. I'm not going to spend time to do that. So that's one triangle. But then our other possible triangle, we have to label out as well. Now in this one, B is still 23 degrees. A is still 8. B is still 6. Okay, C we'd still have to find. But in this case, A was 148.6. And angle C is 8.4 degrees. And now you can use this angle of 8.4 degrees for C with the law of sines to find side C, which again, I'm not going to spend the time. So here we see two possible triangles from little side, big side angle. Okay, again, the process is set it up. Now we're solving for the angle, so we have to use arc sine. Use your knowledge of how the unit circle works to say, if I know this angle, what other angle gives me the same sine? So I find the same y value and I solve for that angle. Let's look at another example. Find angle C, given angle A is 57, side A is 15, and side C is 20. All right, so let's draw our triangle. Try and make A around 57, something like that. So let's say, okay, A is 57. Side A is 15. It doesn't matter how we label it otherwise. I'm going to call this B. I'm going to call this C. Like this. C is 20. We want to find this angle C. All right, so our law of sines. A, side A over the sine of angle A equals side C, okay, which is 20, over the sine of angle C, which we don't know. Now solving using cross products. 20 times the sine of 57 degrees over 15 is what the sine of C has to equal. 20 times the sine of 57 divided by 15. Now we find C by taking the arc sine of all of this. Okay. So I grab my calculator and I'm going to type this in. Inverse sine, 20 times the sine of 57 divided by 15. And right there, I get an error domain message. Okay. If I just typed in, okay, so let me quit out of this. If I just type in 20 times the sine of 57 over 15, okay, just this part is equal to about 1.1. Okay? And can a sine of an angle be equal to 1.1? No. 1.1 is outside of the range of sine. The sine of C can't equal something bigger than 1. So this, okay, notice again, is little side, big side, angle. Okay? It's our dangerous one, okay, which we've now have seen produce two possible triangles, but now we've just found out a situation where there are no possible triangles. We can't have the sine of angle C equal to 1.1. Not possible here. It tells me this is too short. If I swung this on a circle like I had in GeoGebra, it actually wouldn't reach that side length. And let's see, I'm not going to spend the time on the video. I could make this in GeoGebra where I made this angle 57, I made that 20, and I made this 15, and what would happen is it would look like this, right? Here's 57, here's 20, 15 would look something like this, where it just can't ever reach that bottom side to connect it as a triangle. So there's 0 possible triangles. Okay. All right, last example. Find angle A if B is 117.32 degrees, side B is 67.25, and side C is 16.3. All right, so angle B, this has got to be an obtuse triangle, so I'm going to draw something like this. I'm going to call this A, this B, this C. This is 117.32. Let's see here. Side B is 67.25, and side C is 16.3. Now let's look at what we have here. Again, this is side angle. The angle is not the included angle between the sides. Now this time, this is the bigger side, this is the smaller side, and that's our angle. So this is big side, little side, angle. Big side, little side, angle. And if we go back to what we talked about, big side, little side angle is a one possible triangle. We kind of go, oh, okay, I know there's just one possible triangle here, so let's find it. All right. So I am asking you to find angle A. Notice to find angle A, we have to know side A. That's not going to work, so we're going to have to work with angle C here first. So we're going to take 16.3 over the sine of angle C equals 67.25 over the sine of angle B, which is 117.32. So the sine of C equals, cross multiply and divide, 16.3 times the sine of 117.32 over 67.25. I will then take the arc sine of this, and I get C is about 12.4 degrees. Okay. Now what we can do is we can say, okay, if this is 12.4 degrees, what is our angle A over there? Well, we take 180 minus the 117.32 minus the 12.4 that we just got, and this is 50.28 degrees. I'll just say 50.3 degrees. There we go. Now, if you get uncertain, like, okay, is big side, little side angle the one possible, or is it the 0, 1, or 2 possible cases? How do we handle that? Well, if you get 12.4 from the arc sine, okay, I would still recommend taking the time to do this. Okay. Let's draw our unit circle, and we got an angle of 12.4 degrees. What other angle will have the same value for sine? So what other angle has the same y value? This one does. So, well, I know this is also 12.4 there. So this angle from here all the way to there is 180 minus 12.4 degrees, which is what? 167.6 degrees. Did I do that right? 180 minus 12.4, 167.6 degrees. There we go. So we could say, whoops, wrong direction. Or C is about 167.6 degrees. However, when we get that angle, we should look at this and we say, okay, C's 167.6, but B's already 117.32. Is it possible for C to be that big of an angle? No, just with these two angles, we've surpassed the 180 degrees. So this is not possible. There's only one possible triangle in big side, little side angle. We already knew that. We saw that before. But this is how you can confirm, okay, by looking at your unit circle, finding that other angle that has the same value for sine, and looking at what happens when you put it in. It's not possible for that to be 167.6 degrees. Just not possible. There's only one possible triangle here. All right, that's going to conclude my videos here on our setup. We have some other things that we can do with law of sines, but we're going to wrap it up. Thanks for watching.